Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! So now we're going to get started in testing these preamps. And I was going to show you the gear that I'm going to be using. First is the scope. This is a mid-80s vintage Tektronix 2235 100 millihertz dual channel scope. Had this thing for decades, been a real workhorse. Turns out it works really great with tube amplifiers. So this is what we're going to be measuring the waveform patterns with on this first step, which is the analog testing. Got our isolation transformer 1-to-1 that allows us to isolate the ground of the unit under test from the mains earth ground. We always want to have this unit grounded and the unit under test ungrounded through an isolation transformer. Just having the ground pin not connected isn't enough because the neutral still hooked to earth ground. So make sure you use an isolation transformer. The next thing, here are little dummy loads. Got one at 100K, which is what most tube amplifiers have for their input impedance. And then I've also got a 50K load, which from my research is where a lot of solid state amplifiers run. And I know that some people will be using these preamps to drive a solid state amplifier. So I wanted to check how well each of them does under two different loads. This is our little signal generator. It's a old Tenma analog. It works great. It's solid state. It's not a tube signal generator, but I got it for about $100 on eBay. Replaced some of the electrolytic capacitors, and it's worked really well. I like it has just a knob that you can turn. These are the buttons for the different scales. Here's the amplitude, and then it's got an attenuator knob to get different scales. And it's been really a good way for me to get sine waves and square waves into the devices I want to test. And then here's the first unit we're going to be testing, the little preamp we built. Sorry if this video is a little shaky. This is handheld, but I'm fixing to pop the camera on a tripod and get to testing this unit. We'll be right back. Okay, so here's our base scope pattern. This is the output from the signal generator, and I have it on channel 1. And then this channel down here is going to be the second channel that is going to the output of the preamp, so we can see what's going in versus what's coming out. Let me center this up on the screen there. Just like that. We're going to move. We're going to go ahead and switch this to 2 volts to make this smaller. And we can move it up here to the top of the screen and get it out of the way. Give some room for this. I'm going to start off on, make sure the probe's on ×1. And we're going to go 5 volts per division. That means each one of these divisions will be 5 volts for this line, and it's 2 volts for this line. So we got 3 volts going in, and have the volume turned down. And I'm going to jump back here once the preamp's had a little time to warm up. You want to make sure that the tubes are nice and warmed up before you start testing. And I think we've given the amp enough time to warm up. Let's turn off the invert. And it looks like this thing's going to put out some juice. And there's clipping. You can see it. And it's kind of interesting if you watch, if I push it, it clips and then kind of rounds back off. But it's still clipping right there when it's wide open with 3 volts peak to peak coming in. So let's turn it down just a breath to about there. And let's see what we've got coming out. And it's a little easier to put the bottom on this scale here. So we know we're at this line. We're at 5 volts per division, so that's 5, 10, 15, 20, 28 volts peak to peak coming out. And that's into the 100K load. So the next thing I want to do is swap the output load and see how this preamp drives a 50K load. I don't know if I said 100 ohm, it's 100K ohm load was the first one. So let me switch this dummy load to the 50K one, and let's see how this preamp drives a little harder load, which would be what we would see from a solid state amplifier. Now obviously there's some amplifiers that are outside the norms of both these tests, but I feel like this is pretty common of the 2 different loads that this preamp would see. So let's see how it does driving a solid state load. And it's definitely clipping right there. Maybe just a little less right there. It's having a little harder time driving that. But we're still getting 5, 10, 15, 20. We're getting 22 volts driving that load. Just want to go back and double check this one. This is the 100K load. And that's 5, 10, 15, 20. Yeah, it's only a couple more volts. I may have counted that wrong earlier. This is 20, it's like 23 volts. And it was 22 volts going into the other load. So, looks like it's very similar, but into the 2 different loads. I don't think it's going to have a problem driving either type of amplifier. So now the next thing we want to do is ensure both channels are working like they're supposed to. So we're going to leave the 100K load in there, and we're going to switch to the other channel and turn it up and see what we've got. Wow. That's not good. And obviously the other channel was putting out a lot more voltage. So we've got some troubleshooting to do. I'm not sure what's going on, whether we've got a resistor in the wrong place or, I was pretty careful assembling the board. The first thing we want to do is try swapping the tubes from one channel to the other and see what that does. So let me pause here and swap the tubes around. Okay, so we took the tubes from one channel and put them in the other channel, and let's see what happens now. There we go. Exact same thing. Phew! Looks like we just got a bad tube. These were brand new Electro-Harmonix 7025 preamp tubes, and obviously we've got a bad one. So let me try, because I do have some 12AX7 tubes, which are electrically the same thing, and let me try swapping some tubes out and figure out which tube I have that's bad and continue from there. Okay, so here we've replaced the second tube, and there we go. So that back tube was bad. This is the one the closest to the output. But I'm noticing something here with this 12AX7. I'm not seeing the clipping that I was seeing on the other channel with the 7025 tubes. So I want to try putting two 12AX7s in this left channel and compare it to the right channel with the 7025 tubes. And then possibly switch them back and forth between channels to make sure it's the tubes I'm seeing and not the something different with the channels. Okay, here we have two 12AX7s in the left channel, and let's see what kind of drive we're getting out of this preamp now. As you can see, there's no clipping. I want to see, that's 5, 10, 15, 20, 25. We're getting almost 30 volts peak to peak out of 3 volts in, which is 10 times what the signal is going in. And let's see where this thing does clip. I'm going to turn up the voltage in, and there's some clipping. So we can get 30 volts peak to peak out of this preamp into this 100K load before we see any clipping. It's a lot of gain. That could definitely drive an amplifier that had a low input sensitivity, and possibly even an amplifier designed to use this preamp might even be able to skip one of the voltage amplification stages. So I want to switch it to the other channel that we have the 7025 tubes in. And again, compare the gain between these two channels. Yeah, see, it's clipping right there. So we're getting a good 5 volts less peak to peak of drive with the 7025 tubes versus the 12AX7s, but we don't know what they're going to sound like. The 7025s might be quieter, they may have less hiss, they might be just overall better sounding tubes, and so we'll reserve judgment on that until we can actually listen to this preamp. The next thing I want to do is take a look at the square wave. And I've learned in the past that we need to go back and adjust the output of the signal generator to get it back up to 3 volts peak to peak. And there's 3 volts peak to peak, or real close to it. Got a pretty clean square wave. It's a little distorted on the front end, but it's not bad. So then we'll switch this back to 2 volts to get this up out of our way. And let's see what the square wave looks like. Now that's a nice square wave. It's a little tiny bit rounded off on the front end. But remember, this amplifier does have global feedback from the cathode of the output tube back to the cathode of the input tube. And that's one reason that this thing using 4 12AX7 tubes doesn't have just monster voltage gain, is that it does have a healthy dose of negative feedback. So just to look at, I'm going to turn up the frequency, and I'm seeing the same amplification across the frequency range, which is telling me that it's probably got a pretty flat frequency response. Even the low frequency response looks good. The amp looks pretty good to me. I'm going to jump back now to our next amp that's in the test and see what it looks like. Okay, the next preamp we're testing is one that a nice viewer sent to me to test, upgrade, and put into the shootout. This is supposed to be a clone of the Marantz 7 preamp. It's got 2 rectifier tubes, some little 7-pin guys, and then it's got 2 12AU7s and 2 12AX7s. And haven't been able to hunt up a schematic yet for this, but honestly I haven't spent a lot of time researching this one yet. But I want to go ahead and throw it into this initial analog test and see what kind of performance it has. So we've got the 100K output load on it with 3 volts peak to peak going in, and this one's got a lot less output or gain. We're looking at 5, 10, 12 volts peak to peak. Looks like maybe 13. Let's call it 13 volts peak to peak. And I've checked both channels and they're the same. So this one's got a lot less gain, which might be good depending on what use you have for it. Most people probably are wanting to put this between a line in and their amplifier, so they may not need the gain that other amplifier has. And sonically, I don't know what this one's going to sound like. So, you know, if you can hear Dolly came down here to get a drink right in the middle of that. But anyway, so let's try a different output load and see how this thing does on a 50K load. And this time we're putting it up on a 50K load like you would see in a solid state amp. And again, it looks like it's putting out maybe a half a volt less. It's real close. So again, this amp should give you the same performance on either a 50K or 100K impedance amplifier, which is the majority of the stuff that you're going to run into trying to drive one of these with. And then let's see what this thing looks like with a square wave. And again, I need to... It's the only thing I don't really like about this signal generator, when you switch to square wave, you have to adjust the output to equal what it has with a sine wave, which I'm sure a modern one doesn't have those issues, but work with what we got. So here comes the square wave output. And this one actually looks like it's rolling off just a tad more. But it's still, I don't see any ringing. I don't see anything that's jumping out at me as being a problem. And it's amplifying the square wave at almost the same voltage as it did the sine wave. So I think we're fine there. Let's see if as we turn the frequency up, we're getting the same amplification. And then let's switch down. And we're getting the same amplification down here too. So should have a nice even frequency response. So for the last test, let's throw the other preamp on here and see what it looks like on these analog tests. And while I haven't seen the schematic for that previous Marantz 7 clone, I suspect that it's got a healthy dose of negative feedback in its circuitry too, and potentially using a 12AU7 instead of a 12AX7 for the voltage multiplier is why we saw a little less gain, well, about half the gain that we saw out of the Conrad Johnson preamp that I built. So the last one we have here uses two 6S7s, and it has no feedback. It's a direct coupled pair, very similar to what the original 300B front end was like, except the second tube is a cathode follower, and they're direct coupled. Have no idea what this thing's going to put out. Okay, first thing to notice is the signal's inverted. So let's switch that, which isn't a big deal, but it is inverting the signal, and wow, this thing's putting out just crazy amounts of gain. It's not even starting to clip, and it's maxed out the scale on the screen. So at 3 volts in, we've got 5, 10, 15, 20, 25, 30, 35 volts peak to peak. And I'm going to have to switch it to the 10 times multiplier to see if we can see where this thing starts clipping. And then let's switch the scale to 10 volts per division and turn up the... No, nothing yet. So this thing will put out some crazy amounts of drive. That's 10, 20, 30, 40, 50, 60, 75 volts and still not seeing any clipping. Let's go up one more scale and see if we can even get this thing to clip. Okay, it's not clipping, but that's a monster distortion we're seeing. That's 6 volts in. This would be 20 volts per division on this side. That's 20, 40, 60. Looks like you can get 60 volts peak to peak out of this preamp before we get into visible distortion. So let me flip this back down to 1. Turn this back down to 3 volts peak to peak. That's what we started with. Crank this thing up. That's 10 volts per division. Makes it a little easier to count. So that's 10, 20, 30. Actually, let's go. Let's flip our, I think we can use the 1x multiplier again. And that's 5, 10, 15, 20, 25, 30, 35, 40 volts peak to peak. So at 3 volts in, we're getting 40 volts out. So this one's got more drive than either one of the other two, which could be a good or a bad thing depending on how sensitive you want the preamp to be. And again, I didn't see really heavy distortion, but we really won't know until we get this thing on the Analog Discovery 2 Audio Analyzer Suite and see what the THD numbers really are. Let's take a look at what the square wave of this thing looks like. And let's hope that we don't have a problem there. Let's back up. There's 3 volts peak to peak square wave. And this one definitely, that line isn't as flat, and it definitely rolls off more on the top end. Let's see how this does when we change the frequency. Looks like the amplification stays pretty stable with frequency. And then let's switch this back. But yeah, it's getting uglier on the low end than the other 2 amps did. And it's actually doing really well for an amp with no feedback. So there are 3 preamps run through the... Oh, I did forget. We need to... Let's go back. We forgot to check this one on the... with the other load to see if it has a problem dealing with driving a solid state amplifier. So let's switch that load real quick. And I haven't dug into either one of these other amps to check to see like what the heater voltages are and if the transformers look like they're appropriate to be running 120 volts, what kind of plate voltages we have and all that kind of stuff. So still got some stuff off camera that I want to do. But yeah, this thing doesn't... It's not going to have any problem driving a 50K ohm load either. So all 3 of these would work fine on a solid state or a tube amp. You don't have to be concerned about, hey, they're not going to be able to drive a solid state amp. That's not going to be a problem. So anyway, there's the story. The little 6SN7 amp has definitely got the most gain. Looks like 40 volts out of 3 volts in. The Conrad Johnson's in the middle with 30 volts, which is a 10x gain over the input signal. And the last one, the little Marantz 7, has got 13 volts out of 3 volts in. So it's a little less than 5 times. So we got 3 different gain amps to choose from. Anyway, the Analog Discovery 2 with the Audio Analyzer Suite, checking the harmonic distortions and those kind of things, I think are going to tell the real story. So, going to figure out how to get all that set up, and we will do that in the next video on these. And then I'm probably going to do some listening tests, do some tube rolling, and look at what modifications I could do to these other 2 preamps that I was sent, as far as coupling caps and that sort of thing, and try to get them as dialed in as I can, and then in the end do a ranking of which one that I think is best. So hope you're enjoying this series. If you are, please subscribe to the channel, like the video, and we'll see you soon for more preamplifier fun. Have a great day.